thanks for inviting me. My name is Harald Kempf. I work for the German National Meteorological Service, and my normal responsibility is handling all the civil protection customers, so strategic development for the civil protection sector. But one of the more special tasks I was given recently was joining in a team of which is tasked with developing a crowdsourcing feature for our main weather app that we offer. And I'd like to share with you some first experience from this. It's a rather fresh project, so some of the numbers will still be preliminary, but I think it might be interesting to just share these experience that we made, because others might think about getting into this as well. So it's always good to see what others did. To give you some sort of background, what we're working with, I put in a few slides about our main tool that we used, so to speak. It's the Warnwetter app. It's available in Play Store, in iTunes. We also had a BlackBerry version going for some time, Windows version. So we developed this app in 2015, launched it in June, and it is the main app of DWD, which is offered to the public in order to communicate severe weather warnings, but it also offers a lot of context information, as we put it. So you can look at the radar, model field, point forecast, quite a large amount of information. And so far, the app has been quite successful. The numbers here are not totally up to date, but we have about 10 million installations over the last 5 years. The number of active users is, of course, much lower, in the region of 1 million. I think our rating also dropped a little bit. There's only one way in one direction in which ratings develop once the apps are on the market. So I think now we are at 4.2 stars. But all in all, we have a quite successful and established weather app, which we already used for some other things that we wanted to do. One of the major new features that we introduced a while ago is the integration of natural hazards. So we developed into a multi-hazard warning app, so to speak, which of course also not only in Germany means it's a multi-actor approach. So what we did was we cooperated with other responsible warning authorities, and substantially worked on aggregating their warnings into one platform, and we were then able to offer them in our app, including push functionality, so information about flooding, storm surges, avalanches. So we've been using the Warnwetter application for different things, and it was only natural that we got interested in doing crowdsourcing through this platform, because we have the established user base, and we knew if we could get this feature to run, it might be a very good response in terms of reports that we can generate. And so we decided to start this development about 2 years ago, starting with the concept phase. We got a lot of input from existing approaches. So very important were the Finnish colleagues from FMI. They started crowdsourcing way back, and we talked to them, and we sometimes copied their approach. This is very helpful if you have some good starting point. In the concept phase, we also looked at of course, functionality and the user interface that we wanted to have. We designed the categories and the values that users should be able to report. Also looking at available, international standards is a bit exaggerated, but we tried to have a look at what others were recording and make it as compatible as possible. In the actual development phase, we were challenged with quite a lot of legal challenges. So the legal framework for all the crowdsourcing was a major step. The actual development was rather painless because we have a company that we work with, and we did this pretty agile using prototypes. And in the end, this led to an incremental rollout of our app. You will see in a minute that the response was quite great, a little bit overwhelming even. So we had to put out some bug fixes very quickly and some performance tweaks and provided some better functionality for it. But all in all, we developed this over the course of, I would say, 1.5 years. And I can already share some lessons learned here. So the legal preparations, drafting up this legal framework, this is quite involved, and you should reserve time for this step, even if it's an ugly step, but it's necessary, and it takes time. We actually did no real large-scale tests before launching. We have a small test group, but larger tests would have been actually useful. So this is something that I can recommend. And you should always include safety margins. I mean, it's pretty obvious, but we were surprised on the amount of response that we got. Yeah, and of course, you should always be ready to bug fix, have a point release out in a few days if there's any trouble. Talking about the legal details, I'll get a bit into it. So because it was very important for our legal department to sign off to be on board with us. And so what we did is we require strict opt-in, so that the feature is disabled. Basically, the users hinted at it during the onboarding, and so he will have to actively accept the terms and conditions. And if he does that, he's on board. He can also opt out at any time. So this was the very important basis. In terms of privacy, we managed to do quasi-anonymous reporting. So we record a device ID, but it's a random string. So we can basically not track anybody, and the spatial accuracy is low enough. So what we actually store is not personal data anymore, at least the common the idea of our legal department. So we are a bit more free to handle the data. We also allow to send in pictures connected to the observations. So that was also quite a challenge, but we tried to do a license which is close to the CC0 license, which is not possible in Germany, but we drafted something ourselves which is very similar to that. So the copyright will always be with the user in Germany, but we will have the full transmittable usage rights, which is pretty much the same thing in the end. And of course, for pictures, we had to include some automatic filtering and reporting to make sure that nothing, suspicious is showed to all the users. So all in all, we launched the new feature in July. So close to half a year ago, and you can see on the left side, this is just taken shortly after the launch, start of August. We had some rain coming through, so yeah, a small storm, and you can see the amount of messages which were sent in. So that was a real challenge in the beginning. It actually overwhelmed older smartphones if you were displaying too many of them, but so we had a very successful start. What you can do is you can report the different observation categories. I'll get to that in a minute, with connected values of. This is an example in the middle of a hail report, and the user can choose a according size of the hail, and he can also annotate that there's any damage. There's also options to add free text comments, and also the option to add pictures as well. So we expanded the functionality already over time a little bit. So what we have now in terms of functionality is that we display a 1 hour time slice of the reports. So this is from 2 weeks ago. You can see the amount of reports coming in per hour. Users can browse through the history up to 12 hours. We limited that just to have not too many observations being loaded every time. Users can also look at the latest reports, so squeeze the amount of displayed messages up to 1 minute. And now they can also filter for messages with images. We didn't include that in the beginning because we were not really sure what kind of images would be reported. So this is the parameter Z. Actually, I didn't change it from German, but you see the connected symbols. They should speak for themselves. So we have lightning reports, which is just, well, users like it, and we have a very good basis for comparison with a lightning detection network. So not the most useful report, but users really want it. We have wind, hail, rain, slippery conditions. We have snowfall. We have the snow depths reports. We have cloudiness. We have fog and tornado reports. And each of these categories has different values, and it can also have special attributes. Like in turn for snowfall, the user can also decide, is the snow staying on the ground? Is there complete cover formed? Things like that. I already mentioned users can send in pictures, and you will see later on a surprisingly large percentage of people use this feature with pretty good pictures actually. And yeah, we have all the usage rights on this. We really hope that this will be useful in providing us with some more idea of the actual impact. And of course, we also want to have a nice photo library to illustrate what kind of meteorological conditions will have which impact, to make it a bit more easy for the user to connect our meteorological forecasts to their experiences. Now, going into the actual quantity, I put in this graph, so it goes to the beginning of November. So this is one period that we chose for the meantime to analyze. So you can see it was about 5 months of messages, and we received in that period 660,000 messages. I put some numbers on the right side, so you can see the peak 2nd of August, basically. So it was 26,000 reports per 24 hours. So this is way more than we expected. The average is also pretty high over the period. You can see we are going into saturation. So I guess in the long run, we'll see about 2,500 reports per 24 hours. And this will most likely increase whenever there's an interesting weather condition. So severe weather, or today we had the first snow. So that will be a nice peak. So far, we had about 125,000 users, which were actively using the crowdsourcing features, so sending in at least one message. And yeah, of course, the cloudiness is the top category. About 20% of people add free text comments to their messages, and so far we've only seen useful comments. We are not displaying them in the app, so it's just a message to the service, and people were using that to convey some additional information as we intended it. So they were quite nicely behaved. Nevertheless, we of course had to make sure that what we display in the app is not complete nonsense. So we were prepared to filter out harmful messages or plainly wrong messages. The way we do this at the moment, I'm just giving you a rough idea of it. So the backend of the application runs in the cloud, and basically we have an input API. The observation comes in. If there's a connected image, it will be stored. Then some automatic image recognition. So we do some automatic labeling on the image, will provide us with further information. Any kind of harmful image will just be deleted. So if there's violence, nudity, or anything like that, we don't even deal with it. So the message just goes to the trash. If not, then the quality control, well, actually, it's more of a plausibility control started, and we have we have a blacklist for harmful users. Basically, I think there's just a few users, so random IDs on there. So the behavior has been pretty good, and we do a plausibility check based on weather conditions. A very coarse one, but these three things, the image labeling, plausibility check, and the blacklist basically determine if the message will be flagged as suspicious or not. And if it's flagged as suspicious, it will not be displayed in the app, just to the user that submitted it. So he will be happy, but nobody else will see it. And we have a database connected to that, and we also have an API, basically just an endpoint where we can get the images and the messages as GeoJSON. So that's the way that it works. And so far, we have been rather happy with the approach that we chose. So I'm listing here the categories and data sets that we use for plausibility checks. So I put the confidential here. Well, it's not really confidential, but we don't advertise how we check in order to not encourage people to beat our check, basically. So most of the things are straightforward. So the main data set that we use for plausibility checks is our radar with different thresholds in different areas. In some cases, we use model parameters to check the cloud area fraction. Of course, for lightning, we use lightning measurements. And yeah, for example, for fog, basically, we don't do any plausibility checks because, well, it would be meaningless, right? We also have an option to do some crowd-based quality control. So if users see messages that they deem wrong meteorologically, or they see any picture which would be inappropriate, then they can just send this in and report a problem. So if it's a meteorological problem, then if there's a certain amount of reports, the message will be flagged as suspicious and removed from the app. If it's a problem with the image, basically the image will be removed immediately. So that's something which we needed to put in order to be okay with our legal department, right? Because we really need to make sure that anything is safe that we show there and have a very quick way to remove anything which is inappropriate. But so far, we didn't have any problems there. So looking at the quality of data that comes in, you can first of all see on the top left what kind of reports are sent in, so which category they fall in. Of course, the absolute majority is in the cloudiness department. So people like to send in pictures of the sky, and well, we put it in to make people happy, and it can be a useful data set. So next thing is basically wind, lightning, and well, obviously rain is the important parameters, the largest bracket. On the top right, I put the amount of suspiciously flagged messages per category, and you can see that for cloudiness or rain, there's a very low amount of messages which were flagged as suspicious. While for all the winter parameters, so slipperiness, snowfall or snow cover, you see a very, very high amount. Well, there were few of these messages, but most of them were just people trying out if they could put a snow height of 50 centimeters in the middle of Berlin in August, right? So it was people trying out if they could get this through. So we see a high amount of suspicious messages there, but the total numbers are rather low. Same thing for tornado. People like to report tornadoes. We got some real tornadoes, but most of them are just false reports, basically. So the plausibility checks is a really tricky thing because you don't want to exclude anything which might add new information. And you have only your old information to check against it. And we were thinking about using clustering or anything like that to have an additional plausibility check. But yeah, the number of reports, it can be very low. So cluster approaches are not the way to go, at least for our reporting so far. Yeah, on the bottom you can see that we have this flag times reported for weather. So that just means how often was the message reported to contain a wrong type of weather, and you can see the numbers. They indicate that people are behaving very nicely. So we don't get that many bad reports. So no complaints there. In terms of pictures, I just put that in here quickly. So most of the pictures are of the sky, as you can see, clouds. Again, this time was 81%. So overall, we have about 10% of messages, or 8.5, which contain image as well. And there has been very few images which with complaints about them. So you see a total number of 69, so or 71. We checked these images. Most of them would have been okay, and the others were just, well, people taking a selfie of them or something like that. So we were surprised that there are almost no joke images in there. So in terms of data integration, we made sure that the data is integrated prototypically into our Ninja workstation so that the forecasters can use it for forecasting and warning services. We're also going to provide it to special users. Since I'm handling civil protection, this will be one of the user groups that gets them in one of their dedicated systems. So because for them, it's also quite a benefit. They've been asking for this kind of impact information for a long time, and now we will be able to provide that to them. Of course, we want to do some data sharing, which is unfortunately a bit more complicated than we were initially hoping. So the legal framework basically allows us to do anything with the data that we want to do. And the thing that we want to do is openly share it. But we do have ongoing legal challenges. So there has been some rulings in court about alleged market distortion. So companies were attacking basically our app. And so we have to be very careful with what kind of data sets we provide. So we hope that we can share the reports as climate data, so just with a time delay of 24 hours or something, and maybe limit the amount of keys that we include. We wouldn't include pictures. So we hope that this will be possible soon. Yeah, we could do some targeted trade or sale, but we want to give them away for free, basically. This would be the idea. So this is not really a good option to trade them. And we are also looking at international exchange, so putting them in EWAP or bilaterally exchanging with other services that do crowdsourcing. So this is, from our perspective, very important. But yeah, it turns out to be a bit more complicated than we hoped. To give you an idea about the broader picture, I put in some of the work packages here, which are connected to the approach. So everything in green is implemented already. We are at the moment working on on-site database integration, and we want to put the messages into our geo server to be able to serve it as geo web service as well. Of course, so far we only did a plausibility check. We want to have a real quality control, so people will start to work on that now that we have some substantial data sets. That should be possible. And later on, of course, we are looking at R&D in terms of using the messages in assimilation, nowcast verification. Machine learning might be a very interesting thing to do on the data sets, especially also on the images. And we want to build something like an impact database. Not sure how to do that yet, but this is at least some of the future goals. So in the end, I put in some possible talking points, so we see lots of untapped potential in this approach. So we get loads of data, and so far we have no experience in how they will be able to improve a forecasting warning. We hope that this will be the case. It really looks like that. Also R&D, we have no experience yet. So people will get to work on this data set now. also one of the points which is very interesting, at least in my sense, is the automatic classification of the images. So we have image labels on them, and they are surprisingly good. So this is a very interesting data set. Lots of open questions pop up, so we have to keep track of versioning. So whenever our app version changes or we change the way that people can report features, we need to somehow keep track of it. At the same time, this is true in the backend. If we change the plausibility check or something, we need to keep track of it. We already did some small tweaking of parameters, so there's deprecated parameters in older data sets. So this is quite challenging. Sharing is again challenging in the sense that we somehow need to translate the messages, so we might use different scales than other services. And some of the next steps for the feature will probably be just improving the user engagement. So we were talking about some mild gamification approach, or at least have options to non-anonymously report. So we need to increase the long-term motivation. That's for sure. We want to tap into special user groups, so trusted spotters, for example. And yeah, it will be a constant task to carefully update the reporting profile. With the experiences that we will gather over the coming years. So, and with this talking points, I'm at the end of my presentation, and thank you for the attention. And hopefully there's any questions.
Sure. So if people would like to ask any questions, you can either put your hand up and or you can use the message box. So have we got a message? Okay, so Brian has asked, have you looked at what sort of format you might exchange data in?
Mm-hmm. Yeah, I mentioned in the concept phase, we were looking at what was out there, right? So, for example, EBOB from ESSL, they proposed already some reporting API. In the end, we settled on a GeoJSON format, which would be very easy to facilitate any exchange, I guess, and it's also easy to read and rewrite. So I guess so far we are happy with the GeoJSON format, so we can export any information as feature collection, and most tools are quite happy to work with GeoJSON. So we think this is a rather good approach so far. But yeah, I'm happy for any suggestion on exchange formats there.
Thank you. I think we'll come to an end now. Oh, there's actually another question. Okay, you've typed an answer. We will come to an end now. We'll pick up some of these questions in further discussions. Feel free to submit any questions and we'll put them into our discussion at the end. But we'll